Okay, welcome. Today we are going to learn how to graph a system of linear inequalities. We have the example up here on the board. Apologize that I'm not the greatest at drawing graphs. Let's take a look. Okay, so when we're graphing our system of inequalities here, let's first graph the pink one up here. We'll just label this as number 1, and then the blue one we'll label as number 2. As we're graphing. So I know not all of you might have colors for what we're about to do. Okay, so graphing the first one, I know I go down 1 for my y-intercept. My slope is 1 over 3. So 1, 1, 2, 3. I can connect your 2 points. Okay. Now graphing the second one, I go up 2. Okay. I see my slope is 4 over 3. Well, 1, 2, 3, 4, not going to happen there. So I can go down 1, 2, 3, 4. 1, 2, 3. So about here. So really, I guess it's probably where they cross. Okay. Okay. So now I've graphed the 2 lines. It's my first step I could do. Now I want to determine the shading, because we're dealing with an inequality here. So we could have a bunch of ordered pairs that are outside of our line as our answer. So first, let's worry about the pink line. How am I going to determine the shading for that? Well, one method that we can use is a test point. So test. So the test point for my pink line, usually a good test point is the origin here, and we're going to see if that's part of our solution set. So a test point for 1 is 0, 0. And now we ask ourselves, and I'm going to take that test point of 0, 0 and substitute it in to my inequality and see if it's true. So is 0, substitute that in for y, greater than or equal to 1/3 times 0 minus 1. So is 0 greater than or equal to -1? Well, that's true. So that means that 0, 0 is part of my solution set. So I'm going to shade this way from my pink graph. Okay, now I have to do the same thing with the blue graph. Okay, so I come over here. So a test point for your blue graph, okay, that's going to be 0, 0, because that's another one. It's not on the line, so we can use it. And then we substitute that into our inequality here. So is 0 less than 4/3 times 0 plus 2. So is 0 less than 2? Yes. That is true. So then I shade towards 0. On my blue line. Okay, now this is a system of inequalities. So what we're looking for is the part where the 2 graphs overlap. If you see down here, this is all blue. Up here on the top is all pink. But if we look here kind of in the middle, we see this area here is where our 2 solution sets, I guess you could say, kind of overlap there. The 2 shadings overlapped, so that's going to be our answer. So the stuff in the orange is what we're actually looking for. That's the solution set to this system of inequalities. And you can take any ordered pair that's inside of this orange, and it will work for both of them. Okay. The final thing that we need to do is determine if our lines are shaded or solid or dashed. You could do this in the beginning, but I like to wait till the end. The pink one has the equal to sign underneath, so that's going to stay a solid line. The blue one does not have the equal to sign, so we have to make this a dashed line. If you wrote this in pen and you're really lazy, just write dashed, and I'll kind of know what you were talking about. Okay? So again, this color here in the orange is our solution set for that system of inequalities. Okay? Okay, we could try one more out here. Let's kind of erase all this. Keep up my beautiful graph. I'll just erase the whole thing. That's a shame. Okay. Again, don't laugh at how terrible I am at drawing. But good practice for all of us. Okay, so the system that we're going to look at this time, first one we're going to have is 2x plus y is less than or equal to 1. And then the other one we'll have is x minus y is less than or equal to 2. Okay, these are a little bit different. We don't really know how to graph these. So one method we could take is we could put them into slope-intercept form. Then we know how to graph them, life is good. So I'm going to subtract 2x from the pink one. So now I'm going to have y is less than or equal to negative 2x plus 1. Here, I can subtract x from each side. So now negative y is less than or equal to negative x plus 2. Now I need to get rid of the negative sign, so I'll divide by negative 1. Divide each term by negative 1. So I have y, and don't forget when you divide by a negative, your inequality sign flips. We have x minus 2. So here's my first equation. Here's my second. Okay, graphing these, for the pink one, I go up 1. Your slope here is negative 2 over 1. So I can go down 2 to the right 1. Down 2 to the right 1. Okay. And then my next one, I start at down 2. And your slope's positive 1, so up 1 over 1. Yeah. The scale is not perfect, but it gets the job done. Okay? So you could use test points here for the shading, but we're going to kind of look at it a little bit different with this one. So again, test point is 0, 0. If you feel comfortable with that way, go right ahead. What I'm going to look at, though, is with the pink, I'm saying all my y values have to be less than or equal to this right here. Okay? So if I'm looking for the y values that are going to be less than this line, I'm looking for the y values that are going to be going down this way, that are less than it. So that means I'm going to be shading that area right there, because that's all the y values that are less than that pink line. Like 0, negative 1, negative 2, negative 3. And then for the blue line, I'm looking at the y values that are greater than that blue line. Well, the ones that are going to be greater than the blue line are going to be like negative 1, 0, 1. So I'm going to shade all of that. Because those are all the y values that are greater than that blue line right there. Now I just need to find the area where the two lines intersect or overlap. Well, this is just blue. There's nothing here. This is just pink. But this area here, and it kind of looks like it's pink, but okay. This whole area here, the orange and purple, that's my answer. That's my solution set. That's where the two shadings overlap. That's what we're worried about. And the final thing, I just have to determine if they're solid or dashed. Well, pink has an equal to, so that's solid. Blue has an equal to, that's solid. So they're both good to go. So again, you could have used a test point here, and you easily could have figured it out there. Or you could just kind of look at the inequality and determine which way to shade from there. Okay? So hopefully that answered all your questions. See you later.